So here we have an exponential equation, and you may be looking at this thing like thinking you never learned how to do an exponential equation before, and that's okay. I know my students don't get to this until long after they take the standardized test in the spring, but let's try and reason through how we're going to solve this thing. First, I want to talk about what this is not. What this is not saying. This is not 32 times negative 2x plus 5 equals blah, blah, blah on the right. Okay, it's not a times, it's an exponent. And what that means is you have 32 raised to some power. If you had 2 to the 5th power, right, if you work through what that is, that's going to be 32. 2 times 2 times 2 times 2 times 2, right, 5 times. It's like that, except the exponent in this case is just this ugly thing, this negative 2x plus 5 thing. And don't be frightened off. We can solve these things. What you do is you take your equation, negative 2x plus 5, and on the right side we have 8x plus 4. And usually, almost always, you're going to have a situation where you can change this base of 32 and this base of 8 so they match each other. And once they match each other, everything gets so easy. So let's rewrite 32 and 8 using a common base. In other words, I want, in that parentheses, I want something that looks very much the same on both sides. So how am I going to do this? Well, let's think about 32 and let's think about 8. 32, I just mentioned it. 32 was 2 to the 5th power, right? Let's just work with me here. 32 is 2 to the 5th. What's 8? Well, that's 2 to the 3rd, right? You can see now I have a common base. This is what I mean by common base. It's 2 for both of these things. And there's a very powerful thing you can do with exponential equations once you have a common base. And that is to just cross out the bases. It's like dividing both sides by a number or adding the same number to both sides. You can cross out the base on both sides as long as it's the same base. So let's work with this equation a little more. We're not quite ready to do that step yet. I've got 2 to the 5th to the negative 2x plus 5 equals 2 to the 3rd to the x plus 4. And if you remember how exponents work, this is equivalent to 2 to the 5 times negative 2x plus 5 on the left, and on the right, it's equivalent to 2 to the 3 times x plus 4. And now is the part where you can just cancel out numbers, because 2 to some power equals 2 to the other power. That means the powers themselves must be equal. I'm going to cancel out the 2 from each side, which gives me this. 5 times negative 2x plus 5 equals 3 times x plus 4. And I want you to appreciate why this has to be true. I mean, think about what would happen if this were not true, if these two things did not equal each other. Then you would have 2 to some number x, and you would be saying, that's the same as 2 to some other number y. Well, what if x and y are different? I mean, would you really come along and say, 2 to the 3rd power is equal to 2 to the 4th power? That's nonsense. Of course, they're different. So these exponents have to be the same because the bases are the same. So now, what have we got here? We've just got a simple linear equation. We can solve this one. This becomes negative 10x plus 25 on the left and 3x plus 12 on the right. And now you just rearrange until you get everything, all the numbers on one side and all the x's on the other. So I'm going to add 10x to each side, and I'm going to subtract 12 from each side. That gets me 13 on the left and 13x on the right. Look at this. X equals 1. Okay, that was kind of cute how that worked out. But the idea is the same. Every time you have this equation, or something like it, an exponential equation, look for a common base. Once you have a common base, simplify your exponents, like I did here, okay, in this step, and then cross out the bases. Those 2's are the same thing. You cross them out, and then you have a simple linear equation.